The People's Pharmacy podcast is supported in part by CocoVia. CocoVia cocoflavanols support both cardiovascular health and cognitive function by promoting healthy blood flow, transporting oxygen and nutrients to vital organs and muscles, including your heart and brain.
CocoVia now comes in an even more concentrated formula, with 450 milligrams of cocoflavanols, 5 times more than the leading dark chocolate bar and 15 times more than the leading cocoa powder.
CocoVia has a proprietary process that preserves cocoflavanols at the highest levels, and the product undergoes rigorous testing at every stage, which allows them to guarantee the highest level of cocoflavanols per serving and to provide the purest, highest quality product possible.
People's Pharmacy listeners can now try CocoVia for 25% off by using the code Peoples25 at cocavia.com. That's CocoAVIA.com. Alzheimer's disease robs people of their memories and their identities. To date, we don't know the cause and there is no cure. This is the People's Pharmacy with Terry and Joe Graydon.
Scientists know that Alzheimer's disease is associated with plaques and tangles in the brain. The plaques are composed of a peptide called beta-amyloid. The pharmaceutical industry has spent enormous sums developing drugs to eliminate beta-amyloid. Are they barking up the wrong tree?
A Harvard researcher suggests that amyloid beta is part of the brain's immune defense system. Could it be serving a useful function?
Coming up on the People's Pharmacy, a re-evaluation of the underlying factors behind Alzheimer's disease and what you can do about them.
First, this news. Welcome to the People's Pharmacy. I'm Joe Graydon.
And I'm Terry Graydon. Alzheimer's disease is a growing public health crisis. It's estimated that nearly 6 million people are currently living with this form of dementia. Within 3 decades, that number is expected to swell to 14 million.
The scientific understanding of Alzheimer's disease is changing. One researcher in the forefront of the new paradigm was Dr. Robert Moy. We spoke with him in 2018 to get an update on his exciting research. We were deeply saddened to learn of his death late last year at the age of 58. Dr. Moy was assistant professor in neurology at Harvard Medical School and assistant professor in neurology at Massachusetts General Hospital Neurology Research.
Welcome to the People's Pharmacy, Dr. Robert Moy.
Hi, very glad to be here. Thank you for inviting me.
And thank you. Dr. Moya, for decades, the leading theory of Alzheimer's disease and dementia is that the enemy within our brains is amyloid plaque buildup. And yet, most of the drugs that have been designed to reduce amyloid beta have been incredibly disappointing. Hundreds of millions, maybe billions of dollars have been spent. You offer a whole new concept behind the function of amyloid beta in the brain. What's it doing there?
Yeah, so for probably 3 decades, the primary idea guiding therapeutic approaches has been that amyloid and the little protein that forms it, A-beta, are accidents. That A-beta, this little protein that globs together and forms amyloid, is an accidental product of catabolism and has no physiological function. And the idea has been that the amyloid forms drives the next major Alzheimer's disease pathology, which is called neurofibrillary tangles, which is another protein that coagulates into long threads inside of neurons. Amyloid forms outside. And then those together drive inflammation. And the idea has been that amyloid is poisonous to neurons, kills them, which is a reasonable idea. But the last few decades have seen a lot of data that suggests A-beta is anything but a functionless piece of metabolic junk. For instance, it's 400 million years old. The human A-beta sequence is found in coelacanths. That's an ancient, used to be called fossil fish, living fossils. And it's in 60% of all vertebrates, not just mammals. And so that suggests that it's doing something, and it's doing something important.
It certainly does, because when you have something that lasts through so many different types of animals, we call it highly conserved. It usually means it's something pretty critical.
It is. And in fact, I could only find one protein that's more conserved across that immense amount of time. I mean, that's before there were insects. So the question, of course, was what was it? And rather serendipitously, we came across another protein, a little protein called LL37, they were like peas in a pod, A beta and LL37, so many similar activities. But LL37 wasn't considered junk. In fact, it's the archetypal human antimicrobial peptide. So an antimicrobial peptide is part of the innate immune system, our most ancient arm of immunity. And it is a natural antibiotic, and it also stimulates immune response, inflammation. And so we tested.
Now, let me just pause for a second, because the idea that the body makes these natural immune products, almost like antibiotics, but perhaps even more powerful than antibiotics, probably come as a surprise to people. These are not antibodies.
No, they're not. They are part of a very ancient immune system called the innate immune system. And antimicrobial peptides are to the innate immune system what antibodies are to our more recent immune system called the adaptive immune system. So antimicrobial peptides are the foot soldiers of innate immunity, and antibodies are the foot soldiers of adaptive immunity. Now, there's not clear distinctions between those. There's a lot of overlap. But innate immunity is really what protects worms, and cockroaches, and beetles. It's very ancient, and vertebrates have evolved a more sophisticated adaptive immunity, which includes antibodies, and it means that once you acquire immunity, you keep it. Innate immunity doesn't work like that. It pretty much does the same thing every time, and pretty much the same thing to whatever you throw at it. And it doesn't give you immunity if you've been exposed to a pathogen once. If you get infected again, it does the same thing all over again. So in that way, it's a bit less effective, but it's still absolutely vital. If you don't have innate immunity, you're going to be dead in a few hours from raging infections. It's really what keeps everything checked in your mouth, in your gut, on the surface of your skin, keeps microbes from overwhelming you. So in the brain, the innate immunity is the only game in town, because the brain is what they call an immunoprivileged organ. So adaptive immunity can't get in there, because it's a fairly rough kind of immune response, adaptive immunity, and it would be very damaging to the delicate tissues of the brain. So innate immunity, which is a bit less violent, is really the main way that infections in the brain are dealt with. And it turns out that A beta, rather than being this piece of junk, is actually a very potent antimicrobial peptide. And just by comparison, for some organisms, it's 100 times more effective than penicillin. So it's a pretty potent little protein. But the really interesting thing about it is how it does that. And the way it does it is it forms amyloid and traps the bugs. So it literally encapsulates and permanently sequesters them into these amyloid deposits, which we call plaques, amyloid plaques, which you find in huge abundance in Alzheimer's disease patients.
Dr. Moy, what kind of bugs are there in the brain?
Yeah, so that's obviously a question, and the sort of knee-jerk interpretation of our finding is that Alzheimer's disease must be some sort of infection. Well, that's not as outrageous as it sounds. There's been a small group of people saying that for many years, and indeed if you'd talked to people before the discovery of A beta, most of the AD researchers would have said it is an infection. In fact, Alois Alzheimer was the first guy to suggest it. But the thing is, it's a little bit more complicated than that, because there's no single pathogen that crops up in every AD case. So it seems that it's not so much a classical infection as possibly a combination of microbial organisms causing this problem. So about 18 months ago, we started what we've called the Brain Microbiome Project. So we've been looking in brains to see what's there. We do it with a process called deep genomic sequencing, which basically involves looking at DNA and looking for non-human sequences. And the findings were both very surprising and very exciting. We found over 220 bacteria that seem to be living regularly in normal people.
That's extraordinary. I think that if you had asked most patients and perhaps most health professionals 20 years ago, are there bugs in our brain, microbes, bacteria, viruses, fungi, stuff?
What does the microecology of the brain look like? I think people would have given you a blank stare.
Well, they'd say, the brain is sterile. There's nothing growing in there, just as we used to think the lung was sterile. In fact, except for our digestive tracts, the colon, we thought, the body is pretty devoid of stuff, pathogens. But you're saying you found 220 different bacteria in the brain?
Indeed. And the whole concept of the sterile body is kind of starting to fade away. There's a microbiome of the blood. In every mil of blood, there's about 1,000 microbes. And as far as the brain's concerned, people knew for quite a while that there was various populations in there. For instance, viruses. There's a number of viruses, particularly herpes viruses, that pretty much 100% of people have. Herpes 6. A lot of people have herpes 1. They usually acquire them before the age of 2, and they're lifelong. So the virome, as it's known, has been known about for quite a while, and there's probably a dozen or so. It turns out there's more than a dozen, but that's been known for quite some time. Plus there's toxoplasmosis, of course, the little amoeboid. So that's estimated to be in 1 in every 5 people. Its normal host is the cat, but it's found its way into us. And so, there's over 1 billion people on the planet with that thing living in their brains. So it's not exactly strictly sterile, but I don't think it was appreciated just how many different microorganisms there seems to be living in our brain. And they're not just sitting there doing their own thing, they are interacting. And you can do an analysis that looks at those sort of interactions, and what it tells us is that sometimes they cooperate, sometimes they compete. They really are an active microbiome and not just passive residents.
You're listening to Dr. Robert Moy, assistant professor in neurology at Harvard Medical School. He's also assistant professor in neurology at Massachusetts General Hospital Neurology Research.
Terry, it's unbelievable. I mean, I'm just amazed that we have so many different bacteria and viruses in our brains.
More than 200 different types of bacteria from healthy people.
And, there's just been a study published several weeks ago suggesting that herpes 6 and herpes 7 viruses may be implicated in Alzheimer's disease.
Well, the levels of those viruses were twice as high in the brains of people with Alzheimer's disease as they are in healthy individuals. So it doesn't say it's cause and effect, but it certainly looks suspicious.
And it looks as if people who have evidence of those infections may have a faster decline. So it may be interacting in some way to cause problems in the brain. Well, after the break, we're going to find out what those microbes are doing in our brains.
Is it possible to have beta amyloid and those tau tangles, but not dementia?
What makes brains of Alzheimer's disease patients so different from others?
Is it possible to correct the microbiome balance in the brain? How could we get rid of the bad actors and boost the beneficial ones?
Learn how this research could help in preventing or reversing dementia.
You're listening to The People's Pharmacy with Joe and Terry Graydon.
The People's Pharmacy podcast is sponsored in part by Kaya Biotics. Kaya Biotics offers the first probiotics which are both certified organic and hypoallergenic.
All probiotics are produced in Germany under laboratory conditions with high-quality ingredients and under strict regulatory oversight.
The 3 available formulas are created for very specific purposes, such as strengthening the immune system, fighting yeast infections, and helping with weight loss.
To learn more about Kaya Biotics probiotics and the important topic of gut health, you can visit their website, KayaBiotics.com. That's Kaya Biotics.com. Use the discount code PEOPLE for $10 off your first purchase. Welcome back to the People's Pharmacy. I'm Terry Graydon.
And I'm Joe Graydon. If you would like to purchase a CD of this show, you can call 800-732-2334. Today's show is 1132. That number again, 800-732-2334. Online at peoplespharmacy.com. You can also download the podcast from iTunes.
The People's Pharmacy is brought to you in part by BrainGauge, developed by neuroscientists at the University of North Carolina to track brain health. Available for home research and clinical applications. Online at gaugeyourbrain.com.
And by Red X Industries, makers of utterly smooth creams and lotions that deeply moisturize to make dry skin feel soft and smooth. The number is 800-345-7339. The website is uttercream.com.
Our topic today is Alzheimer's disease. What causes the underlying pathology that ultimately leads to dementia? The track record of the pharmaceutical industry has been disappointing. Targeting tau tangles and amyloid beta has produced disappointing results, although a new trial on an anti-amyloid medication produced confusing results. Headlines declared the drug to have big promise, while others reported little clinical efficacy. What do we need to know about amyloid and Alzheimer's disease?
Our guest is Dr. Robert Moy, assistant professor in neurology at Harvard Medical School. He's also assistant professor in neurology at Massachusetts General Hospital Neurology Research.
Dr. Moy, what the heck are those microbes doing in our brains? I think that's a fascinating idea, but also kind of scary.
Yeah, professionally fascinating, personally rather disturbing is how I think about it. But that's the million-dollar question, and we really don't know. This is quite new data. We haven't even published it yet. But it's been emerging over the last few years that there is a lot of interaction with the microbes in your gut with the brain. For instance, there's some what are called short-chain fatty acids that microbes generate that need to travel into the brain in order for immune cells to mature correctly. And that was something that took everyone by surprise. And
wait a second. Immune cells in the brain. You said the brain was immune privileged. So
it is.
You're talking about a specific immune cell that belongs in the brain?
Yes, it's called microglia.
Okay.
And they're members of the innate immune family of immune cells. They're not like white blood cells that make antibodies. They're a separate group. And so they're normal residents, and their job is actually to clean up debris, fight bacteria, but also to nurture neurons. And in fact, they're one of the brain's big caregivers. But when you get inflammation, they kind of get switched into soldiers, and it may well be those cells actually that do most of the neuronal killing. It used to be thought that A-beta was neurotoxic and did the damage, but increasingly that's looking like it isn't. There's these brains, Teresa Gomez actually in our institute's been collecting for nearly 15 years, and they're called resilient brains. They have massive amounts of amyloid and tau, but no inflammation, and they're no dementia. So
whoa. That's incredible. Yeah. So you're like turning the entire Alzheimer's disease hypothesis on its head, so to speak.
Somewhat. I mean, the amyloid cascade hypothesis, which is the thing that's been really guiding research and therapeutics, has always assumed that amyloid produces downstream pathological processes that lead to dementia. So in that sense, it's consistent with that. But the difference is that for a lot of the models that were out there, it was the amyloid that was doing the damage. But what we see is not really the amyloid, it's the consequences of the amyloid fighting the good fight, if you like.
So in other words, the amyloid beta is kind of our defense system at work. And if it works, if it's doing its job effectively, it may be able to control the infectious process and reduce inflammation. When it loses the battle, that's when all hell breaks loose.
Yes. So this microbiome that we see in the brain, the really stunning thing we saw is when we looked at AD brains, and the pattern there is very different, distinctively different.
Oh, well, tell us more about that.
So you've got less diversity of microorganisms, and you've got some what you could call bad players coming to the fore. So they're bacteria that are often associated with inflammation, and they seem to have gained ground. And some of the viruses also seem to have really ramped up their game. So something like herpes 6 is what they call slow and low, so it just sits there and doesn't do much. But if there's a disruption, it'll take advantage of it. It's an opportunistic pathogen, and it'll start reproducing at a furious rate. So what we think, our current model now of Alzheimer's disease is not quite as simple as a simple infection, but more what's called a dysbiosis, which means an imbalance in the microbes that are resident in your brain.
You know, it sounds a little bit like inflammatory bowel disease in the digestive tract, like Crohn's disease.
Yes, that's the model that we're looking at and following. So that's exactly the kind of thing that we're thinking it's like. Rather than a single bacteria or a single virus, it's dysbiosis and imbalance. A beta rises to do battle with some of the bad players that are potentially really dangerous, and fights them, keeps them under control. But the long-term consequences of that war, the collateral damage, ultimately triggers a series of pathological events ending in disastrous inflammation. It effectively activates all these microglia, the caretakers, turns them into soldiers, and when that happens, they start a rampage that causes massive neuronal death.
Bacteria make toxins. And it's not just the bacteria itself that are causing the problems, but these toxins are also very challenging and can cause all kinds of mischief. Does amyloid beta have any activity against the toxins?
Indeed it does. In fact, we're starting to think that may be one of its main jobs, is to clear away endotoxins that bacteria secrete. Some of them are deliberate endotoxins, some of them are probably accidental, just products that they make in their normal living processes, but which aren't very good for us. So A beta seems to be able to target those and once again lock them up in amyloid and prevent them from from damaging the delicate tissues in your brain.
It seems to me that creating antibodies, which is what some of the drug companies have tried to do, to in essence get rid of amyloid beta and reduce some of the plaque, might be counterproductive. I mean, the drugs haven't worked, for one thing, but are they actually maybe undermining the immune system trying to fight off these pathogens?
It's possible that there are two aspects to that. Firstly, they haven't worked very well or at all. But the problem there, it seems, is that we're using them in the wrong time. It's what my colleague and mentor Rudy Tenzi calls the 3 R's: right patient, right time, right place. And so if you're going to tackle amyloid, you need to tackle it early, before there's clinical symptoms, in fact, when the amyloid is starting to be laid down in large amounts. So if you're going to clear that away, that's when you have to do it. Well, all the clinical trials to date are way down when you're starting to get early dementia, mild cognitive impairment. And essentially that's like if you imagine amyloid is like a match and tau pathologies and are like the bushfire, and inflammation is like the forest fire. That's a bit like blowing out the match after the forest is on fire and expecting it to help.
Right.
And it's not going to.
Well,
so,
but it's such an interesting problem, because how do you identify a person just when this process is at its very beginning, when blowing out the match would make a difference?
Well, that is the major problem with anti-amyloid therapies and tackling A-beta, and there is no blood test. And even now, over 100 years since Alzheimer, the only positive diagnosis of Alzheimer's disease is post-mortem examination. We've got a lot better at diagnosing people with the disease, but we have nothing for trying to work out who's in the early stages of it before there are clinical symptoms. There are some brain imaging systems out there that can sort of see amyloid accumulating. They have some potential, but they're not really going to be much use for large-scale screening. And even then, it's a fair way down the track that they're really detecting large amounts of amyloid. So that approach is really a major problem. The other approaches, which are rapidly emerging as what most large pharmaceutical companies that are in the AD field are looking at, are anti-inflammatories. These are not like the anti-inflammatories that you are aware of now. Most of those target adaptive immunity. So what you need are anti-inflammatories that go after innate immunity. And there's not a lot of those out there at the moment.
Now, Dr. Moya, I have to say, if the microbiome is where the action is, all of these bacteria and viruses and perhaps even fungi, it sounds like what we really need to do is be able to reestablish a normal balance once things start getting disrupted. And maybe we need more of this amyloid beta. Maybe we need antivirals. Maybe we need certain antibiotics. I mean, if the source of the problem are bugs in the brain, how do we get rid of the bad actors?
Yeah, that would be ideal if you could reestablish balance, and the problem would probably fade away. But it's not clear how to do that. One interesting thing is the idea of a gut microbiome and a blood microbiome and a brain microbiome is a bit of a human construct, I think. It's more – the microbes don't think of it that way.
They go wherever they can.
And they think of it as all the human body microbiome.
We're fair game wherever they land, huh?
Yeah, and it's the body microbiome, and they communicate with one another. So bugs living in the brain do seem to communicate with microbes living in the gut. And there's a major nerve called the vagus nerve that runs between the brain and the gut. And it's literally a highway for all sorts of things to move up and down. I mentioned earlier some of the metabolites from the gut microbiome that are necessary for the brain to mature. Well, that's where they travel. They travel up there, and various things from the brain travel back down. And among those, we think, and this is speculative, are what they call quorum molecules. That is, messages between these pools of bacteria where they talk to one another. And so it may be possible to modulate what's going on in the brain by modulating what's going on in the gut.
So, Dr. Moy, when you talk about quorum molecules, you're talking about something that would essentially sense how many of us are there and what are we about to do? Yeah,
it's like, how are you? Oh, I'm okay. What are you going to do? Oh, I was thinking going pathogenic. How about you? You in? Yeah.
Oh,
that's
boy.
That sort of discussion. But, I mean, that model is highly speculative. We really have to develop or generate data to support it. But it's based on some of the kind of studies we've been doing with transgenic mice, where we're doing fecal transplants, and we're able to modulate the amyloid deposition in these mice.
Dr. Moya, there's some interesting research that's been done in the last couple of decades with regard to this idea of fecal transplants. So, for example, people who develop a C. diff infection, which is just, a really bad actor in our digestive tracts and can lead to uncontrollable diarrhea, they have been treating these folks with a fecal transplant in order to kind of reestablish a more normal microbiome in the lower gut. Would that be beneficial for the brain?
We don't know, but it's a potential kind of strategy, something along those lines. We started doing it because we looked at the gut microbiome of our Alzheimer's disease mice, and they were highly disrupted. So we re-established the normal microbiome to see if that affected what was going on in the brain, and it does seem to have. So unfortunately, mice are not, people aren't 200-pound mice.
Right. And there's a lot of things that work against Alzheimer's disease in mice that don't work in people at all, right?
Yes, that's right. They're not very good models. I've never been very impressed with Alzheimer's disease mice. I think too much faith has been put in data generated from them, and it's somewhat gratifying to see that pharmaceutical companies are moving away from them too. That doesn't mean they're useless or they don't have a role, but there's certainly limits on what you can discover using them. And what we've been messing around with is suggestive, but it doesn't mean that would work in humans, unfortunately.
Dr. Moy, very briefly, can you tell us what research you're looking forward to now?
Well, certainly sorting out the microbiome in the brain, that's very interesting stuff. And the potential there is well beyond Alzheimer's disease, as is this notion of antimicrobial peptides forming amyloid. It's not widely appreciated, but diabetes is an amyloid disease too. And there's a little peptide called amylin that does pretty much in the pancreas what A-beta does in the brain. And so we've tested it, and it is a super potent antimicrobial peptide. So once again, the process in the pancreas was viewed as an accident, but maybe not.
So in terms of prevention and treatment, I mean, that's what our listeners are really interested in. How can I prevent dementia? And if I start to show signs of cognitive impairment, is there anything I can do to control it or reverse it? If you had to look into your crystal ball, where is your research leading us?
I think it's probably leading towards anti-inflammatories that target innate immunity as the most likely short-term treatment for Alzheimer's disease. Beyond that, interestingly enough, the same things that protect your cardiovascular system will also lower your chances of getting dementia. That is good diet, exercise, don't hit the booze too hard. All the basic things that you should be doing anyway to stay healthy will give you some protection from dementia. It doesn't eliminate the chance, but it certainly reduces the risk.
What are you telling your family and friends, and what are you doing yourself, given the insights you have gained from the laboratory?
Just what I said. Good diet, exercise, stay fit, stay healthy. And those things are your best protection at this point in time.
Dr. Robert Moy, thank you so much for talking with us on the People's Pharmacy today.
Thank you for having me.
You've been listening to Dr. Robert Moy, assistant professor in neurology at Harvard Medical School. He's also assistant professor in neurology at MGH Neurology Research. He and his colleagues published an article on this concept of A-beta as protective in Neuron just last month. You'll find a link to it from our website.
After the break, we'll talk with Dr. Dale Bredesen and learn more about the brain's ancient immune system.
Can we look at Alzheimer's disease as a protective response to specific insults or pathogens?
How does the microbiome of the brain fit into Dr. Bredesen's understanding of the multifactorial nature of Alzheimer's disease?
You're listening to the People's Pharmacy with Joe. This People's Pharmacy podcast is brought to you in part by Verizana.com.
Verizana Lab offers home health tests that allow you to monitor your hormones and health conditions. You can take control of the quantitative assessment of your health and learn about male and female hormone balance, the stress hormone cortisol, leaky gut, gluten intolerance, or your gut microbiome.
Take a more active role in tracking your health and take 20% off your first order of a mail-in testing opportunity with the discount code PEOPLE. That's PEOPLE, all uppercase. To learn more, go to Verizana.com. That's Verisana.com. Welcome back to the People's Pharmacy. I'm Terry Graydon.
And I'm Joe Graydon. To purchase a CD of today's show or any People's Pharmacy broadcast, you can call 800-732-2334. Today's show is 1132. That number again, 800-732-2334, online at peoplespharmacy.com. You can also download the free podcast from iTunes or from our web store. We invite you to consider writing a review.
The People's Pharmacy is brought to you in part by BrainGauge, developed by neuroscientists at the University of North Carolina to track brain health. Available for home, research, and clinical applications. Online at gaugeyourbrain.com.
The People's Pharmacy is brought to you in part by Red X Industries, makers of Utterly Smooth Foot Cream with shea butter, helping dry, cracked feet feel utterly soft and smooth. The number is 800-345-7339. The website is uttercream.com.
Today we're discussing the complicated science of Alzheimer's disease. There remains a lot of confusion and controversy about the underlying causes of this debilitating condition. Is there anything people can do today to reduce their risk of developing dementia?
To answer that question, we turn to Dr. Dale Bredesen. He's an expert in the mechanisms of neurodegeneration and has served on the faculty at the University of California, San Francisco, and UCLA. He directed the program on aging at the Burnham Institute prior to joining the Buck Institute for Research on Aging as its founding president and CEO. His book is The End of Alzheimer's, the first program to prevent and reverse cognitive decline.
Welcome back to the People's Pharmacy, Dr. Dale Bredesen.
Thanks very much. Thanks for having me, Terry and Joe. Appreciate it.
Dr. Bredesen, we've recently interviewed Dr. Robert Moya, who is, together with his colleague, Dr. Rudy Tanzi, kind of out there on the fringes of Alzheimer's disease research. And what they found was that there are connections between Alzheimer's and what they refer to as the brain's ancient immune system. Please tell us your thoughts on this rather radical research and what it might lead to in the future.
Yes, and actually this fits perfectly with what I wrote in the book. In fact, I quoted their work in the book, and it fits perfectly with the work that we have discussed previously on your show, with the idea that, in fact, what we call Alzheimer's disease is actually a protective response to three fundamentally different insults. And so one of these is anything that causes chronic inflammation. Yes, as you indicated, as Robert has found, you're making this amyloid because you are fighting various pathogens. And by the way, you're also making it if you don't have pathogens, but in fact you have a poor diet or things like that. Anything that causes chronic inflammation, that's what we call type 1 or hot Alzheimer's disease, inflammatory. And then, of course, you also make the amyloid when you have a decreased amount of trophic support, hormonal support, nutrient support, trophic factor like nerve growth factor and brain-derived neurotrophic factor. And that's what we call type 2 Alzheimer's, or cold or atrophic Alzheimer's, and different presentation. And then, of course, number 3 we talked about before, which is the toxic form. You also make the amyloid because it's a very good binder of things like mercury and biotoxins. And so if you're exposed to those things, then you have an Alzheimer's as well. So the reality is, what's been claimed that this amyloid is causing the disease is, in fact, it's a mediator. It's not the cause. And in fact, we need to look very carefully, which is what we do with all the patients, at all of the contributors to this disease. So more and more, we think about amyloid the way we would think about napalm. If you've got the bad guys breaching the border of your country, you may use something like that to try to kill them. But in so doing, you are now limiting your country's arable soil. You're literally pulling back. And that's what the brain is doing when you have Alzheimer's disease.
Pathogens. You mentioned pathogens, and of course, that's something that's been relatively unwelcome in the field of Alzheimer's disease research because it implies there's something that we could maybe acquire, like maybe a viral infection or maybe a bacterial infection. So when you say pathogens, what are you talking about and what might they be?
Yeah, this is a great point. And again, it's important to understand the difference between our old-fashioned diseases, our 20th century diseases like pneumococcal pneumonia, where we have one pathogen and you can treat it with an antibiotic and you're done. With 21st century diseases, all the rules are broken. It's different. So with Alzheimer's, we're really looking at the response to the pathogens. And so it's not one pathogen. As you know, groups have studied herpes simplex or P. gingivalis, which is from oral bacteria, so-called Fusobacterium nucleatum, another oral bacterium, spirochetes, Lyme disease. All of these different things, fungi, have been identified in the brains of Alzheimer's patients. So the key here is that it's not one pathogen. It is a response that can occur to many different pathogens. Therefore, we need to seek the causes and look at all of the contributors when we're looking at someone with cognitive decline or with risk for cognitive decline. And then we need to identify these, and you're absolutely right. Treating these is a separate issue that can be helpful as well. But what we call Alzheimer's, again, is a pathology which is showing a response, much like tuberculoid leprosy. You probably remember that leprosy comes in two different types. Lepromatous leprosy, which is where you don't have much of an immune response. So what do you have? You have a lot of organisms and very little response. Tuberculoid leprosy, very different. Few organisms, lots of response, lots of immune cells. That's what Alzheimer's is like. Lots of response, very few of the organisms. And so we need to recognize that when we're looking at how to deal with Alzheimer's disease.
Dr. Bredesen, I think a lot of people are probably surprised to hear about the concept that we have microbes in our brain. Can you expand at all on this idea of a brain microbiome?
Yeah, this is a really good point. And of course, I was taught in medical school, as so many of us were, that the brain is a sterile organ. There should never be anything up in there. One of the questions that's unanswered yet is whether there is a normal brain microbiome as there is a normal gut microbiome. I believe that many would say, of course, there should not be any microbes there, and anything you find there is abnormal. And I think whereas others would argue, well, we're finding it more and more and more, and maybe, in fact, there is a normal brain microbiome. At this point, we simply don't know. The bottom line is you do find a number of different agents in the brains of patients with Alzheimer's, and these include fungi and viruses and oral bacteria and spirochetes and things like that. To the extent that these are normal, then there would be an altered microbiome. We just don't know yet.
Dr. Bredesen, many of your colleagues in the field are looking for a magic bullet. In fact, there was an article in the paper just recently coming out of Montreal suggesting that if they could just figure out the gene, and in fact, they've identified the BMI1 gene, and they say in mice, it triggers and accelerates the pathological aging of the brain and eyes. And once they figure out this one problem, then they can cure Alzheimer's disease. You've likened Alzheimer's disease to a roof with, the last time we talked, 36 holes in it. And trying to patch one of the holes, whether genetically or with some kind of fancy new drug, is probably doomed to failure. Have you found more holes? And how do you deal with this idea of, oh, we've just found the key thing and now we can cure Alzheimer's disease?
Yes. And if you lined up all of the claims and all of the papers that said, if we just find that one disease, you'd have a very, very long list. It's been about, too much microglial activity, too little microglial activity, a virus, a bacterium, a spirochete, ApoE4, insulin resistance. You could just go on and on and on. This is the whole point of this. This is the reason it's important to understand the big picture in Alzheimer's disease. All of these different pieces contribute. So yes, it is like a roof, and we know of a few more holes now. As I mentioned when we talked before, it's not going to be 1,000. It's going to be dozens. And we know about a number of these things that all contribute. And let's go back for a moment to, the concept of 20th century diseases versus 21st century. When you talk about pneumococcal pneumonia, you're talking about something where, yes, you're going to have a greater likelihood of developing pneumococcal pneumonia if you have alcohol on board, for example, if you have a high glucose, diabetes certainly is a predisposer, if you have poor B cell function, if you have multiple myeloma, you are at increased risk, on and on. However, the pneumococcus itself is such a critical contributor that you can get away with simply giving an antibiotic. And you can, the fact that these other things are important, they're not nearly as important as the pneumococcus. So you can get rid of this with antibiotics. Now, that's in direct contrast to a disease, these complex chronic illnesses like Alzheimer's or cardiovascular disease or osteoporosis, things like that, where it's typically not one thing. In that case, you line all these things up and they're all making pieces of contribution. And so therefore, to get the best outcome, you need to identify all of them and then deal with them. So you literally are patching multiple holes in your roof. You want people to have insulin sensitivity restored. You want them to get rid of the pathogens that are causing the inflammation. You want them to resolve the inflammation. So things like resolvins are critical. If they have toxins on board, which many do, you need to deal with those as well. And most of the people that we see who have Alzheimer's disease have between 10 and 25 different contributors to the disease. And it's by identifying and dealing with all of those that you see these unprecedented improvements in patients.
Dr. Bredesen, what have you and your team learned in the first 5 years of your project, Recode?
Yeah, so a number of things have come out of this. And one of them is that we find that people do best when one of the things they do is to produce relatively good levels of ketones. So if we recommend that people get a ketone meter and look at their beta hydroxybutyrate, that's a critical ketone that your body makes, because as long as you are fueling the brain with high amounts of glucose, you are going to develop the very insulin resistance that contributes to Alzheimer's disease, and that has been associated repeatedly in epidemiological studies. When you now decrease that, you need to have something to replace the fuel, and ketones turn out to be a very good way to go. And of course, there's been a lot of talk about this with things like coconut oil and MCT oil and things like that. You can also produce this with exogenous ketones, ketone salts or ketone esters. And of course, the best thing is to produce it endogenously with things like exercise and fasting and things like that. But some people, of course, don't have the adipose tissue to produce that ketone level. So one of the things we've learned is that ketones are critical to getting best in a cognitive function. And we typically want to see people between 1.5 millimolar and 4 millimolar beta-hydroxybutyrate to get a best response. The second thing we've found is that it is important to address as many of the contributors as possible. The third thing is that as I mentioned earlier, most people have more than one contributor. So they don't just have 100% type 1 Alzheimer's or 100% type 2. They may have 70% type 1 and 20% type 2 and 10% type 3. So that it's important to identify all of these things if you do have toxins to be able to respond to those. So we're learning new things. And in fact, one of the things that we found is that it's very helpful to have what we call PRPs. These are patient researcher partnerships. As you know, doctors are busy. They are not doing many of the tests that you need to look at these complex chronic illnesses. So it's actually helpful. And some computer experts have said, well, patients need to take care of themselves. They need to look at patterns and things like that. That's all well and good. But it's helpful to have someone to work with so that you can have someone say, okay, here are the tests that I've done. What are the other things you suggest? And you work with someone essentially in these PRPs with small numbers of patients interacting with researchers to determine what are the drivers of these complex chronic illnesses. If you go back to what we learned in medical school, you realize the majority of the diseases we learned about in medical schools do not have a known cause. When they taught us about lupus or polymyositis or Alzheimer's disease or hypertension for that matter, they said, look, here's the drug you use to make these better. But they didn't say, hey, here's how it works. So 21st century medicine is about why, not just about what. And therefore, having these sorts of partnerships very helpful to determining why each person developed an illness. And then, of course, because so many of the things that are in the armamentarium for these complex chronic illnesses are benign things. The appropriate use of things like diet, exercise, sleep, stress, brain training, targeted herbs, so-called neuroceuticals, all of these things are things that are benign and used in the right way at the right time for the right person can be very, very helpful in the right combination. So all of these things have been coming. One of the other things we've learned from the first 5 years of RECODE has been that we can look at other diseases. So we're starting to work with people who have other neurodegenerative diseases as well and seeing similar patterns. Now, it's not identical to Alzheimer's, but with modifications, we see similar sorts of stories.
Dr. Bredesen, we love the idea of patient-researcher partnerships. How can patients who are interested connect with a researcher who will be helpful?
It's a great question. And at the moment, these are just beginning. And so the easy thing is to talk to researchers who are interested in your area, whatever it is that you have or are interested or have as a family trait or as a family risk. The other thing, go to the website, drbredesen.com, and let us know that you're interested in this sort of thing.
Dr. Dale Bredesen, thank you so much for talking with us on the People's Pharmacy today.
Thank you so much, Joe and Terry. I appreciate it.
You've been listening to Dr. Dale Bredesen, author of The End of Alzheimer's, the first program to prevent and reverse cognitive decline. We spoke with him by Skype.
We spoke earlier with Dr. Robert Moy, assistant professor in neurology at Harvard Medical School, and you'll find some interesting links to information from both of our guests at our website, peoplespharmacy.com.
Lynn Siegel produced today's show. Al Wadarski is the engineer. Dave Graydon edits our interviews.
The People's Pharmacy is produced at the studios of North Carolina Public Radio, WUNC.
The People's Pharmacy theme music is by B.J. Liederman.
The People's Pharmacy is brought to you in part by BrainGauge, developed by neuroscientists at the University of North Carolina to track brain health. Available for home, research, and clinical applications. Online at gaugeyourbrain.com.
To buy a CD of today's show or any other People's Pharmacy broadcast, you can call 800-732-2334. Today's show is 1132. That number again, 800-732-2334, online at peoplespharmacy.com.
And when you visit that site, you can share your thoughts about today's show.
At peoplespharmacy.com, you can also sign up for our free online newsletter or subscribe to the free podcast of the show. When you sign up for the newsletter, you'll get our free e-guide to favorite home remedies. In Durham, North Carolina, I'm Joe Graydon.
And I'm Terry Graydon. Thank you for listening. Please join us again next week. Thank you for listening to the People's Pharmacy Podcast. It's an honor and a pleasure to bring you our award-winning program week in and week out. But producing and distributing this show as a free podcast takes time and costs money.
If you like what we do and you'd like to help us continue to produce high-quality, independent healthcare journalism, please consider chipping in.
All you have to do is go to peoplespharmacy.com/donate.
Whether it's just one time or a monthly donation, you can be part of the team that makes this show possible. Thank you for your continued loyalty and support. We couldn't make our show without you.